Section 2.5 is perpendicular lines, okay? And objective 3 in this packet. So do a warm up. We did something very similar to this. Actually, we did this problem in, I forgot which packet, but we did this one. So get the measure of angle 1, 2, 3, 4. 4 when A is 90 degree and B is 93. When measure of angle 1 is 90 degree, measure of angle 1 is 93. Okay, so when this is 90, these are linear pair, right? You just learned that, so this have to be 90. These are linear pair, so this have to be 90. These are linear pair, so this have to be 90. So one is 90, then you know that they are all 90. For the similar way, for B, when it's 93, these are linear pair, so this have to be 87. And since this is 87, this should be 93. But you also know that these are vertical angles, right? So these have the same angle, and these are vertical angles. So if this is 87, then this should be 87. Okay? Okay, so we are here. And objective 3 in this packet. So apply the definition and theorems about perpendicular, that's the sign for perpendicular lines. Okay, all right, so here's the definition of perpendicular lines. Definition of perpendicular lines is that if line JK is perpendicular to line MN, line JK is perpendicular to line MN, written that JK is perpendicular to MN, then each of the numbered angles is a right angle, a 90-degree angle. And you remember the definition you can write as a, the converse, and then it have to be also true. If converse is not true, it's not a definition. So here's the converse. If any one of the numbered angle is a right angle, a 90-degree angle, then JK is perpendicular to MN. Okay, so but this has a diagram, so numbered angles, but you can also say that if the angles formed by two lines are 90 degree, if any of them is 90 degree, then lines are perpendicular. That will be the converse. And if lines are perpendicular, then all four angles are 90 degrees. So those are the definition of perpendicular lines. So you can also say that JK is perpendicular to MN if and only if all the angles made by two lines are right angles. Okay, so that's the biconditional way of saying the definition. Okay, and here are the three theorems that stems from this definition. If you just and then using the vertical angles, supplementary angles, and the complementary angles, you can prove these three. Okay, so I'm going to make doing this 2-column proof for 2-6 sticker problem. So you can do this after you finish the packet, this packet and the programs. You can try this. Okay, and you can turn it in tomorrow. We are going to do these part in the video and part in the homework on next page. Okay, so here are the proofs for the first one, the theorem 2.4, and this one is theorem 2.5. By the way, before we go there, let's just see here, read the theorems. Okay, so 2.4 is if two lines are perpendicular, then they form congruent adjacent angles. That's theorem 2.4. And if two lines form a congruent adjacent angles, then lines are perpendicular. What's the relationship between these two? Yeah, they are converse of each other, right? That if that's a P and that's a Q, then that's the Q and that's a P. So these are converse of each other, right? And we are going to call this a perpendicular line theorem. And this is converse of perpendicular line theorem. That way you don't have to spell all this out when you use this as a reason in proof, okay? So look at the difference between the definition and the theorems. The definition says if the lines are perpendicular, all four angles are right angles, right? The theorem 2.4 says if lines are perpendicular, then those lines form congruent adjacent angles. So these are congruent adjacent angles, these are congruent adjacent angles, these are congruent adjacent angles, and these are congruent adjacent angles. Which is different from saying that these are all right angles. The definition is that these are all right angles. This theorem says if this is perpendicular, then these are congruent. These adjacent angles are congruent. And the same thing here, if the two angles, so this one, the definition is that if they are all right angles, then lines are perpendicular. Or actually, if any of them is right angle, then it's a perpendicular line. The 2.4 says that if two angles, the linear pair, are congruent, two lines form a congruent adjacent angle. So if two angles are linear pair and they're congruent, then the lines are perpendicular. Okay? And 2.6 is a little different. It says if the exterior of two adjacent acute angles, are perpendicular, if this is perpendicular, then these two angles are complementary. Remember, complementary means they add up to 90. Okay? Before we work on these two proofs for the theorems of perpendicular lines, let's do these first. Okay? We're gonna do like first line and then you do the rest for this one. Okay? So BE is perpendicular to AC and BD is perpendicular to BF. Okay, so these are perpendicular and then also this is perpendicular. Okay, so if CBF is 40, then EBF, this is 90 degree and this is 40, so this should be 50 and so forth. And you can do this. If this is X instead of 40, then this would be 90 minus X and so forth. Okay, so do the rest. Now let's do these. Okay, so this hopefully should clarify some of how to use these lines in proofs and know what the reasons are. Okay, so if angle 6 is a right angle, then these are perpendicular lines. So you remember, if any of these angle is 90 degree, then lines are perpendicular. So that's the definition of perpendicular lines. Okay. And if RS is perpendicular to TV, then 5, 6, 7, 8 are all right angles. Again, that's the same definition of perpendicular lines. Okay. All right, so I'm gonna pause a little bit so you can think about it first. RS is perpendicular to TB, then 8 and 7 are congruent. So now we are talking about congruent instead of 90 degree, and also these are adjacent angles. So it's one of the theorems. And is it the theorem or the converse? Let's look back this page. Okay, so if you go from the perpendicular line to the congruent angles, that's a theorem. And if you go from the congruent angles to perpendicular lines, that's a converse. Okay, so this one goes from perpendicular line to congruent. So this is perpendicular line theorem. Okay, and if RS is perpendicular to TB, the measure of angle 6 is 90 degrees. What is this? Now we're talking about 90 degrees. So that's the definition of perpendicular lines. Okay, and now 5 and 6 are congruent. Those are congruent adjacent angles. Then these lines are perpendicular. So it's going from the congruent angles to perpendicular. So that's converse of perpendicular line theorem. Okay, and then the last one. Measure of angle 5 is 90 degrees. Then these are perpendicular. Okay, if any of these angles are 90 degrees, then lines are perpendicular. That's the definition of perpendicular lines. Okay, so hopefully that made it clear the difference between the definition of perpendicular lines and perpendicular line theorems and then its converse. Okay, now let's go back to these proofs. All right, so complete the proof of theorem 2-4. The 2-4 is that if lines are perpendicular, then they form a congruent adjacent angles. So what you're trying to prove is that given that these lines are perpendicular, 1, 2, 3, 4 are congruent adjacent angles. These are congruent adjacent angles. These are congruent adjacent angles. These are congruent adjacent angles. Congruent adjacent angles. So if you can prove what? Then you can prove that they are congruent adjacent angles. You want to say that, well, you can say that these are adjacent by the diagram, right? That's something that you know from the diagram. You remember those are one of the things that you know from the diagram, adjacent angles. So once you prove that these are congruent, then this is done. So that's the way that you should be thinking. So I want to prove that these all 4 angles are congruent. How do I do that? What's the definition of congruent angles? The congruent angle has the same measure of angles. So if you can prove that these have the same measure of angles, then you can prove that they are congruent, right? And the perpendicular line, the definition of perpendicular line says something. So that's a hint, okay? I want you to try this. You start with L is perpendicular to N, and that's a given, okay? Try to do the rest, and we review this in the class, okay? And here is the theorem 2-5. Theorem 2-5, you have to prove that the converse of it. So if these are congruent adjacent angles, these are perpendicular. This one is a little trickier, so I'm going to do the statements and you do the reasons as homework, okay? All right, so if 2 lines form a congruent adjacent angles, then lines are perpendicular. Given that 1 and 2 are congruent, you want to prove that these are perpendicular. And you remember the definition of perpendicular line is that if any of these angles 90 degrees, then lines are perpendicular. So you want to make one of these a 90 degrees. Okay, so that's the goal. Then you can go to the lines are perpendicular by definition of perpendicular lines. So you start with angle 1 is congruent to angle 2. That's given. Right? And like I said, you want to change this to measure. So measure of angle 1 is measure of angle 2. Line 1, line 2, you need a reason here. And line 3. These are also supplementary angles, right? These are linear pair. So measure of angle 1 plus measure of angle 2 equal 180 degrees. You need a reason for that. Line 4. Since these are the same, I can do this. I can make one of these. So you can make, for example, measure of angle 2 plus measure of angle 2 equal 180. And you know, I intentionally omitted the word so that you know what to write here. Okay, you know what I did here, I hope. And then 5, since there are 2 of the same thing, you can do is 2 of the measure of angle 2 equal 180. Okay. Oh, I'm sorry. This is the same line. Right. So this, since this is just arithmetic, there you don't need a reason for this. You can say or. Okay, this or 2 of measure of angle 2 is 180. And then you have 5 measure of angle 2 equal 90. And I hope you know the reason why you can go from here to here. And since one of the angle is 90 degree, you can say that line L is perpendicular to M by something. Okay, so to complete that, and we do the rest of the problem in the class. See you in the class.